So a set is a collection of objects that are clearly identified. These could be numbers or they could be items that you just use every day. For example, what you wear. So, and that could be shoes, socks, hat, shirt, pants, and so on. And we can represent this in set notation. So for example, if we are considering a set of positive integers less than 10, we can say A is equals to, and then we use the curly bracket before we list those numbers with commas in between, like what we have here. And the same thing applies to what we wear. So W can represent what we wear. And then this is how you represent that set. So W will be equal to curly bracket, and then you just list that. And then the three dots represent and so on. And the same can apply to numbers. So if you're considering numbers that go up to infinity, then you can just list up to a certain point and then you have the three dots. Okay, we have symbols in sets, and in this section we are going to discuss those symbols that are used in set notation. So suppose we consider a set of positive integers less than 10. We want to define specific sets based on this. So for example, we can define set B to be a set of even positive integers less than 10. And this is written as that. So these are basically even positive integers less than 10. And then we can also define set C as odd numbers less than 10, and that's written like that. And also we can define set D as prime numbers less than 10, which are written like this. And then set E as multiples of 11. Um, but now remember, here we are considering positive integers less than 10. But the first multiple of 11 will be 11, and then 22, and then 3. So those numbers are beyond what you're considering. So basically this set here, set E, will be what you call an empty set. So an empty set is basically a set that has nothing in it, because you don't have multiples of 11 that are less than 10. And then set F, if we define set F as multiples of 4 less than 10, then set 4 will just have two uh, numbers, 4 and 8, and it's represented like that. So based on that, I want to discuss a few things here, symbols that are associated with sets. So the first symbol is a symbol for the universal set. And basically the universal set is a set of all elements under consideration. In this case, we are considering all elements, we are considering positive integers less than 10. So that will be our universal set. And we can write it this way. So our universal set will be basically all positive integers less than 10. And we list them 1, 2, 3, all the way to 9, because they have to be less than 10. And use curly bracket and commas, like I said previously, to list them. And then we have a subset. So a subset is basically a set that is contained in another set. Now, if you look at set F, which has two numbers 4 and 8, this set F has all elements of set B. Yeah, 4 and 8 are in set B. So we say that F is a subset of B, and this is the notation for that. And also the same thing applies to C. So all elements in C are in the universal set, which is positive integers less than 10. So you can say that C is a subset of the universal set. Okay. Next, I'm going to move to element of. This is the symbol for element of. Element of is also called a member of. Now, this is any of the distinct objects that make up a set. For example, when you talked about what we can wear, so these guys here are the elements: shoes, socks, hat. These are elements of this set. Yeah. When you talk about positive integers less than 10, these numbers here are elements 1, 2, and 3. All these numbers are elements of that. So basically, from again what we have just looked at, 9 is an element of set C. Obviously, you can see 9 is an element of set C. So we write it like that. 9 is an element of set C. And here 2 is also an element of set D, as you can see here. So 2 is a member of set D. The other notation is not an element of, so that's just the opposite of what I've just said. So this is one of um, any of any one of the distinct objects that do not make up that set. For example, 9 is not an element of set E, and you can check that. Yeah. So set E is an empty set. So 9 is not an element of set E. So we write that. 9, of course, is not an element of set E. And also 2 is not an element of set C, and we write that. So I've already talked about an empty set. So this is a set which has no members. And we talked about set E, which is multiples of 11, which is an empty set. So we say E is just an empty set. And that's the notation for it. The other thing that I want to look at is intersections of sets. So this is the grouping up of the common elements in any two or more sets, because sometimes you can have more than two sets. Yeah, so basically we look at what is in both of those. So this is an example here. We have set C and set D, and we can clearly see that 3 is in both. Yeah, 5 is in both, and 7 is in both. Yeah, remember here we are looking for common elements. So we can say that the intersection of C and D will be those three. Uh, the set representing the intersection of C and D will be represented by that. Yeah, of course it will have three elements which are in both C and D. And then the union of sets is basically a combination of all the elements of any two or more sets that you have. So basically what you're doing here is combining everything, put everything together. Now just remember one thing is when you put sets together, when you list sets, you don't repeat numbers or elements. You don't repeat them. You write only once. So here we have 1, 3, 5, 7, and 9. And here we have 2, 3. So we put all this together and we have all these members or elements in that set. Yeah. So this is a combination of these two. And you can order them anyway. You don't have to order them from the smallest to the largest. The order does not matter at all. Okay, so the complement of a set, this means all of the elements in the universal set, but not in the set of interest. So for example, the universal set that we have here is positive whole numbers that are less than 10, which are given here. And set B is given by that. So the complement of set B will basically be everything that's not in the universal set, that's not in set B, but is in the universal set. Yeah. So basically the complement of B means everything that is not in set B, everything that's not here but is here. And we can, Just cross check here. We can see 2 is there, we cancel. 4 is there, we cancel. 6 is there, we cancel. 8 is there, we cancel. And now you can see that the numbers that we are left with here are these ones here. So we have 1, 3, 5, 7, and 9. And that will be the complement of set B. Okay, so the last notation is the number of distinct elements in a set. That's represented by that. Just count the number of elements in that set. For example, set B has 4 elements, so the number of sets in the number of elements in set B will be equal to 4. Set F, as we saw previously, it has 2 elements, so the number of elements in set 4 will be equal to 2.